Hello, welcome to this session. Before we start, let me tell you a story. A few years ago, I was working at a bank and the team decided to tackle a refactoring. There was a piece of code that was a bit bothering us, so myself and a pair, we started to work on this. We initially thought it would be quite fast to do this refactoring, but days started to pile up on this, and so after 1 day, 2 days, 3 days, 4 days, a week, and we were still not seeing the end of the refactoring. So the typical day would be the same. We would go to the stand-up, we would say, oh, we think we're close to the end, we hope to be done today. And the day would pass, and at the end of the day, we would admit that we were not closer to the end than what we thought we were at the beginning. It continued for a while, and at some point we decided to just cut where we were and do as we could and stop like that. So there was a lesson though here. The lesson was that you can't do refactorings in big bangs. They're very risky, and this is a true problem. So today I'm going to show you with some live coding 2 techniques that will help you to avoid this kind of problem. Before we start, a quick word about myself. So my name is Philippe Bourgau. I'm a technical agile coach. I currently work at Murex, and I help teams to adopt extreme programming practices to make their work more sustainable and more productive. I'm also a blogger, and you can follow my blog at philippe.bourgau.net. Murex. Murex is a software provider for financial institutions, mostly banks. We're more than 500 developers. We've got offices a bit everywhere around the world, and you can follow us on the social media. So thanks a lot for staying with me, and without waiting more, let's dive into the presentation. So today we're going to work on a code base called the Trivia code base. So it's a famous legacy code base for code katas. It was written by J.B. Rainsberger. So it's complex enough to feel like it's real legacy code, but it's simple enough that you can actually work around it and do some things, learn some things. It's a small piece of software that will help you to track what's happening during a game of trivia. So you just tell it what the dice results were, and it's going to tell you where the player is, whose turn is it. If you tell it, if you answered right or wrong the question, it will tell you how many points you have, and eventually who won the game. So let's see what it looks like. So you can see most of the code is only in 2 files. So there's the game runner and the game. The game runner is a main, so we can run it and see what happens there. So it's kind of a log of game. And if we look into the game runner, so it starts by creating a game, adding some players, creating a random, that must be for simulating the dice. And then here what happens, so it simulates a dice roll exactly, and then it simulates a right or wrong answer, tells the game about it, and it continues until there's a winner. Yeah. Just a sample use case for the game class. And if we look at the game class, we can see that so there's some fields here, they're not private, and then there's a constructor, a lot of code, some system out prints there, constants everywhere, code that looks a bit cryptic. It looks even duplicated. Actually, there's more duplication here as well. Yeah, we can see some duplication here. It's still very verbose, noisy. And here we go. Here's all we have. Are there some tests on this? No, nothing. Just a fake test and this runner. That's all we have. So let's see now the golden master. So suppose you've got to do some refactoring in this piece of code. If you don't have any tests, it's going to be risky. And that's what the golden master technique is about. So this technique is about adding some end-to-end tests that are temporary. Meaning temporary because you'll only keep them for the time of your refactoring and then you'll remove them. So why would you remove them? Because actually they're kind of tests that rely on logs and traces to snapshot the behavior of the system. So it's really great. It snapshots the behavior of the system and then you can do your refactoring in the strict sense. But then if you want to maintain these logs and traces, it's going to be a nightmare. So that's why they're short-lived tests. As I said, temporary, and they're typically used to add a first they're a first step into more testing, more refactoring. And now let's see how we can do this on the code. So we have here a trace that we could very well capture and use as a non-regression or non-change actually criteria. What we would like to do, in fact, is I prepared a test for that. So we would like to run main, capture the output in a stream, for example, and then compare this output to a snapshot. Here it is, snapshot. So we can't do this right now. Obviously, the test doesn't even compile. So what we'll do, we'll comment these two lines out for the moment, and we'll see if there would be a way to capture the output of the runner into a stream. So we saw before that the game class is writing a lot of things to system out. So let's try to capture these. So here I'm going to rely on the automated refactorings. I'll first put this system out as, so sorry, I didn't this. I'll capture this system out as a field and I'll initialize this in the constructor. Here we go. I'm going to put this first. And then I'm going to again extract this as a parameter. File stream, fine, print stream. And all the way I can still run my smoke test. It's still working, so that's all the guarantees I can get, but that's good enough for me. So what I would like to do now is to extract this as a parameter again. But if I do this, my smoke test will fail because there's no main class and main method anymore, and your main method can only have a string array argument. So I'm going to undo this refactoring, and first, before I can do this, I'll extract a method that I'll call run that does the exact same thing as the main. But from this run, I can extract now the print stream. And so now I should be able to call, so let's first check that the smoke test works again. Okay. So yeah, it is working, fine. But now instead of calling main here, I can just call run. I don't need these arguments. I need to make this public, so here we go. And let's try to run this test now. So it's passing, but we're not checking anything. So what we'd like to do now is to check this. I don't have snapshot, so I could capture this, run this once, save it to an output file, and then read this output file from the test. But actually, there's a library that can do this for me, and it's called approvals. Approvals.verify. That's all I need to do, and it's going to take care of the file and all. So I like to import this class, and now I should be able to run this test again. And what approval does is that it's gonna open my favorite diff tool and tell me the difference between the received file and the approved file. So here there's nothing in the approved because I didn't approve anything before. So let's approve all of it, save it, exit. And now if I run the test again, it will compare against the approved version. So let's do this. Oh, I wasn't expecting any errors, any diff. So let's see what happens. So we've got dev roll the 1, dev roll the 2. Actually, it's a difference in the dice result. So we can easily fix this. There was a random there somewhere. So if we extracted the random out of this, we would be able to fix the random seed here and make the test deterministic. So let's do this. Random. We can try to run the smoke test again, verify that it still works as before. It does. And now let's run the golden master test again. We'll validate everything because, sorry, discard. I forgot to fix the seed. So let's fix the seed to 6, for example, and run the test now. So I'll validate everything this time. I'll save. And hopefully, if I run the test again, this time it should pass. And it does. So that's first great news. So we managed to pass a test that makes sure that our code doesn't change and we're not breaking the code. Are we so sure about this? Let's run this test with coverage. That's a good way to learn what's going on. So if we do this, we can see that in the trivia, the game runner is half covered. So half the method and 84% of the lines. So if we check here, we see that obviously we're not going through the main, but we're going through all the rest. So that looks fine. And if we check the game here, so it's 98% covered. And actually there's this method that's not covered, but you see it's great because it's not used. So no problem. So we can be quite confident about our testing so far. And so it means we should be able to do some more refactoring after that. So let's get back to the presentation and discuss the takeaways for the Golden Master. The first takeaway is that we can use it on almost any side effects. So not only traces, it can be logs, it can be messages to other services, for example, but you can also add your own. So if you want, you can print some toString methods. You can change the toString methods as long as they're not used in the system. Another important thing to note is that it implies a strict separation between refactoring and feature development. It's really refactoring in the sense given by Martin Fowler, that it's changing the behavior of the code without changing the design of the code without changing the behavior. So anytime you want to change the behavior, your very likely to break your test. So you might need to upgrade your snapshot. So we saw with the diff tool that this can be easy sometimes, but it can also be a nightmare. Anyway, if ever you need to do this, you should be very careful. Another important thing to note is that these tests are not really suitable for pipeline tests. So you can't really put them in your CI. They would be a nightmare to maintain. But the thing you can do is to keep the code to generate the snapshot or your test code and just ignore these tests. And this way you can rerun them whenever you want to update this code or refactor this code. And so now let's move to the second technique I wanted to demo today, the Mikado method. So the goal of the Mikado method is to avoid refactoring tunnels. So the exact situation I described at the beginning, where you spend days and days and days in the refactoring without seeing any end to it. So it relies on a graph of refactoring steps, where you start building this graph from your end goal, and little by little you discover prerequisites until you get to a small prerequisite that you can actually do and commit, deploy all the way to production. This way you're able to release every step independently, one by one, until you reach your end goal. For this to work, you'll need an end goal and a non-regression criteria. So the non-regression criteria is usually some tests, it can be compilation, it can be just peer review, depending on your what you have. And the more you have, the better. But we'll see there's also slight differences between the non-regression criteria you're using. So let's see in practice what the Mikado method is and how it goes. So the Mikado method is a bit like an algorithm. So once you've got your goal, you'll try to change the code to make this goal work, to accomplish your goal. So you'll try it directly and you'll see what happens. So very often it doesn't compile, but it can also just pass. So in this case, you're done. What you'll do is that you'll try trivial fixes, what we call scratch refactoring. And if your non-regression test passes, then you're done. You can commit and stop if you achieved your end goal. Otherwise, with the scratch refactoring you did, you might have understood better what prerequisite steps you need to do before. And so you can extend your graph with prerequisites. At this point, you should revert. And this is the unusual part, is that you'll revert the changes you did completely. You'll get back to a green state where everything is working, you can deploy everything, and so on. And then you can recurse on the prerequisite nodes you just created. So let's see this in practice on the code. So the first thing we need to do is to agree on a goal. So as you can see here, we've got 4 arrays together, and these three have the same size, which means that they might need to be synchronized in some way. Let's see this. Actually, when we add a player, we first add the player's name to this list there, and then we initialize these arrays. So all these collections are definitely synchronized. And so it would make more sense and design would be less error prone if instead of this, we add a list of player, for example, a player class. So that's what we're going to try to do. So before we start anything, we're going to commit. So yeah, we've got the golden master test passing. That's our first step. Commit. And now we're going to start our goal, which is to replace the 4 collections with the list of player. So remember the first step in the Mikado, try to do your change. So let's try to do this. Suppose we wanted to do this. If we try this, we see that we get a lot of errors. So yeah, we've got these accesses that we'll need to remove. There's a lot of things going on here, a lot of things here as well. So if we break down this change in more steps, the steps could be first replace this list by a list of players, and then one by one remove these arrays. And that's what we're gonna do. So let's move back here and write these prerequisites. So we're gonna replace, or rather change type of players to a list of player. That's the first step. Then we'll have another step, which is delete, what was it? The first one, the place array. Remove the place array. The next one, remove the persons array. And the last one was in penalty box. Remove that's it. So we're back. I think we're back in the initial state. We'll check this right now. We'll run these tests, make sure everything is passing. So it is. So if we get back here, what we'd like to do is to change this, that. So we've got some errors. There's an error here. We could do a bit of static class player. So this is scratch refactoring, just fixing something to see if we find more errors. So we'd need a constructor with the player name. And I think that's all. So it means that we should be able to do this if but we'll need to create a player class. That's the first thing we'll need. And we'll also need to have a player name constructor. And obviously to do this, we'll need to have the player class. Okay, so we've got these steps. There's nothing preventing us from doing these, so I think these are really leaves of the graph. What we'll do is that we can now roll back our changes, tag version control, roll back these, and we're back to green state. We can run the tests, make sure everything passes, so that's great. But let's continue our exploration. So another step is to remove the place array. So let's try to do this. Let's delete this and see what happens. So game runner seems to be building this. It's only in the game. The problem is only in the game. So the places are initialized with 0. So it means that we'll initialize. So let's see a bit more. Places are initialized to 0, and there's a getter place, setter place for the player. So it means we need to have a field and player dot place getter. We'd also need to have a add a player dot move to place setter. So this is kind of a setter, and we want to initialize player dot place to 0. Obviously, if we do this, we'll need to do this before. So I can do this there. And so we're back there. Are there anything else? Is there anything else to discover? No. Getters again. Seems we're done. So we can roll back if it can. No, it doesn't want to. So we roll back from here. Here we go. And the tests are still passing. So I could go on and discover everything that's to do in this refactoring for the 2 other arrays, but I'm not going to do this for time's sake. Just trust me, it's very, very similar. So it means that we are now in a place where we can start to work on the leaves. So the first thing to do is to create player class. So let's start this. An interesting thing here is that we'll be able to do some TDD. So we're changing the legacy code, but we're doing TDD on the parts that will inject there. So this is pretty helpful. It's called bottom-up TDD because you're building things and then plugging them in the code. So to do this, I'm going to create a class called, in here, I'm going to first create a test class. So I'm going to call this player test. Yes. And I'm going to add a first test to test the first thing, which was to have a player constructor. So can build a player with a name. And here we're just going to do a new player, and let's call him Jim. And this should be enough to have this step passing. So I admit the test is really weird here. We don't have assertions. So, but bear with me for a moment. We'll come back to this later. And it's a smell, and it's actually an indication that something is wrong. So let's TDD this. Let's create a play class in this new package. And it's got a string argument, and we'll call this name. That's it. And if we go to player now, we should be able to run this. So I'm going to run everything all together to make sure everything passes. So yeah, this is passing. So we just did this and this. So it means that next step, we should be able to do this. But before we move on to that, the first thing we're going to do is to commit. And we can commit here and have, what did we just do? Create player class with constructor. That's it. So here I'm going to commit excessively during this presentation, just to show you that at every step we're in a green state where we could commit, integrate, deploy, and even push to production. And that's the real nice thing about this technique. And now let's tackle this. So in the game here, we're going to add player there, player here, add an import. Let's see what's missing. So here we just need to do new player. Here it is. And hopefully the test should pass. Oh, yeah, we weren't expecting this. So we see the difference. Here we've got a weird string. Here we've got the player's name. So actually, it's just that we didn't implement toString. That's the typical toString, generated toString. So we're gonna exit this. Remember, in this state, we're gonna revert. Here we go, we're back there. And it means that we need to add an extra step here. So it's add player to string with name. So here we discovered dynamically a new step to make the test pass, but we kept this property of a never passing state. We found an issue, we rolled back, and we're there to add this new prerequisite. So we can do this with TDD, and actually we can even just improve this test. So if we call toString, assertions, assert that new player toString dot is equal to Jim. And now the test looks better. So we just reproduced exactly the error we saw in the golden master output. And what we're going to do to make this pass, we're going to create a field for this name. Generate string method, just print the name, run the tests, and the tests are passing. So here we add player.toString. We can commit this, and if we get back here, so this is green, which means that we should be able to handle this one. So we're back in the game, adding player here, player there, and import, same change I did before. And I run the tests, and this time it's green. So let's commit this, and here I change type of players to list of player. Commit that. Yeah. And this one is green as well. So let's move to these three here. So we'll do these in TDD again. So let's get there. So one is initialize player to 0 and have a getter. So we'll do these two with a single test. Test public void starts at place 0. So if we've got a player, let's call him Joe. And we'll assert that player dot place dot is equal to 0. So this doesn't exist. I'll create this method. It returns an int. I'll return -1 to make sure the test fails. That's it. I'll move this up here a bit. I'll add this to 0, run the tests. It's passing, so it means I can commit. Add player dot place, which means that now I can make this one green as well, and I'll add a final test for this one. and here can move. So it's going to look a bit like this one. So we've got a player, we call him Joe. We're going to move to 5, for example, and here the place should be 5. If I create a method called move to new place, I can now run these tests, make them fail. They do. And so I'm going to fix this by extracting a field called place for that, initialize it in the field declaration. I'm going to make this non-final. In this, we're going to make this place equals new place. And if we run the tests, they should pass. Yeah, they do, which means that we can commit. So we add move to new place. We can commit this, mark this as done. That's it. And so it means we can move to this one. And so here we are. Let's remove this one and let's go through the errors we get. So this should be initializing the place. So this should be done. And now what else have we got? So here we've got some setters and getters. Here we've got some getters and setters. So actually these two sections of the code look pretty similar. Actually, I think they're the same. So we could do a refactoring here. We could extract a method or move this method. Maybe it even makes more sense to move this method in the player class directly. So we could do all this, but we won't do it right now. The thing is that if we do this, we are going a bit outside of the critical plan we have to get our end refactoring done. So what we can do instead is to add some optional steps that we're going to do later. So we call it optional to do later. And here we're going to add something like factorize place manipulation code. So the idea really is that if we keep note of this, so we might do it after, but for the moment we focused on this goal here, and this is not necessary to achieve this. We can achieve this by just going through these steps here, and that's what we're going to focus on first. This way we are sure to deliver the value we want first and not later. And this is typically the kind of thing that makes refactoring longer, because you start with a goal and then you see something along the way. Oh, this is messy. I'm going to change this as well. And this is how you get into really long refactoring tunnels. So here we've got getters and setters. We'll just update these. What else have we got? Getters again. And this is it. So here we're going to place this. Instead, we'll need the player. So there's the player here. We'll extract a variable for this one. We'll extract all of these. So this is the player. And then we'll do something like replace this with player place this. And so this here we need to be careful. So we're going to replace this one. No, not this one. What's the this one as well. So we want to replace this one, not this one, this one as well, this one, and this is different. So here we've got something else. Here we'd rather have player.move to, so it's the setter. Again, the setter. Another error, it's the setter as well. And an error there as well, it's the setter. And so you've got all of these. So we're going to change this. So it's going to be player.get. Oh, so it's players, sorry. Players.get place. Okay, and this should build. And I think, yeah, the file should build. So let's run the tests. Here we are, everything is passing, which means that first we can commit. So we remove game.places, commit. So we can mark this one as done as well. And we could continue for these two other arrays in very similar way. If you've got the chance, try it yourself. It's a great learning exercise. There's a trap in this one because there's actually a bug in the code. So at some point you'll need to update the golden master snapshot. So we're done with this demo of the Mikado method, and let's look at the takeaways for the Mikado method. The first takeaway is that it's way less risky. It's a way less risky way to run large refactorings. Another side effect is that you can cut refactoring so small that you don't have to ask the permission to do it anymore. So you've got a big thing to do. Instead of going to see your product owner or product manager and asking him for 2 weeks to do some refactoring, you can just spend a bit of time to explore it, split it in very small parts, and do a bit every day. And you don't have to ask the permission for that. Another handy benefit of the Mikado method is that the graph can serve as a communication tool. So the whole team can collaborate on a single refactoring. For example, in here, once you've created the player class, you could work in parallel on the player name constructor and the field here. So obviously on this small example, it's not really there's no real interest in doing this. But suppose you were tackling a larger refactoring, you might have work on different classes and there might be more work to do. And this way you can parallelize the work without running into conflicts. We also saw that compilation issues helped us to build the graph very upfront in a very static and plannable way. We encountered one dynamic issue with the toString missing, and so we could extend the graph more dynamically. So that's okay. That's okay. There's no problem with that. Because however the graph grows, you're not very far from a green state. You can always revert, get back to a green state, and everything is working as it used to. So there's no risk really. The only thing is that the more statically typed your language is, and the more you'll be able to plan the refactoring upfront and have a precise idea of how much work you'll need to put into this refactoring. A few other things to note about the Mikado method. If you don't have good non-regression criteria, you can do this as a pair or as a mob, and you'll have better kind of improved bug checking. So that's the way to do things, particularly at the beginning. So you can use the Mikado method to set up a golden master test, for example. And if you don't have automated refactorings, you could use your smoke test or maybe some pair and mob checking 4 ICE principles or many ICE principles to make sure that you're not doing any mistakes while you're setting up your golden master test. Thanks a lot for watching this presentation. I hope you enjoyed it. So I should be around for a while to answer your questions. Thanks a lot and see you soon.